Numbers are often one of the first things you learn in a foreign language, but around the world there's actually a lot of variation in how they're used and composed, so they're not always as simple as they may seem. Perhaps the most basic variable is that of base. A numeral base, or radix as it's sometimes called, determines how high you count before looping back down to 1. For example, English uses base 10. This means that we count our numbers up in sets of 10 before introducing a new word. There are 10 numbers which include the word 20, and then another 10 with 30, then another 10 with 40, and so on. This also influences how we see these numbers. We view multiples of 10 as round numbers, particularly those like 0, 10, 100, 1000, and so on. However, other languages sometimes do things differently. The Chukchi language of eastern Siberia traditionally uses base 20, so only loops back down after counting to 20. This means that 58 is expressed as 2 20s and 18, and 145 is expressed as 7 20s and 5. It also means that the round numbers are 20, 400, 8000 and so on, while numbers like 10, 100 and 1000 are almost as random as 7 or 36 are in English. So, what other bases are there? Well, while mathematically any number can be used as a base, there are only so many which occur in natural spoken languages. The most common, at least today, is decimal, or base 10, which is used in almost all European, Indian, Middle Eastern and East Asian languages. The prevalence of these languages, and of the commonplace Arabic numerals, means that base 10 numbers have spread today, even into languages and areas which haven't historically used it. Perhaps the second most common is vigesimal, or base 20, which we've mentioned. This often occurs in a mixed system, but also occurs pure. We see this system in Basque and Celtic in Europe, Yoruba in Africa, and many languages of the Americas, particularly the Eskimo-Aleut and Mayan families. Duodecimal, base 12, is also somewhat common. It's used in many languages of Nigeria and surrounding regions, but also sees use in parts of Asia. Mathematically, duodecimal may be the best base to use, as it's highly divisible, while still being quite low. There have been several attempts to switch to duodecimal, and it's seen use in areas such as pre-decimal currency, timekeeping, imperial measurements, and in the calendar. Quaternary, base 4, has historically been used by Native American and South Central Asian languages. Quinary, base 5, is used in several Australian and South American languages. Scenary, base 6, is found in some languages of New Guinea and Africa. Octal, base 8, is used by a few North American languages. Quindecimal, base 15, is used by the Huli language of Papua New Guinea. Trivigesimal, quadrivigesimal and septimvigesimal, bases 23, 24 and 27 respectively, are each used in a couple of languages in Papua New Guinea. Duotrigesimal, base 32, is found in the Ngiti language of the Democratic Republic of the Congo. Sexagesimal, base 60, was used in some languages of ancient Mesopotamia, the Akari language of New Guinea, and is used to count minutes and seconds in modern timekeeping and sub-degree measurements. Bases 2 and 3, called binary and ternary respectively, don't occur independently, but can occur as sub-bases, which we'll discuss later. So why are these bases used and not others? And why are 10, 20 and 12 so common, while others occur only in a few languages? Well, firstly, as mentioned, divisibility is important. If a base has a lot of factors, it makes basic calculations easier. 10 isn't the best, but it is a lot better than, say, 7, which is absent from the bases used in natural languages. Lower bases are also easier to work with, as you don't have to learn dozens of words, although if they're too low this can also be impractical, hence why we don't see fully binary languages. The main reason for bases to occur, however, lies in their origins. It may seem obvious, but humans haven't always counted. There will have been a time when we had language, but hadn't yet developed elaborate number systems. Even today, some languages don't count. These are generally small hunter-gatherer societies that just don't need to count things. They can get by being general, just saying a few or a lot. A famous example of these so-called anumeric languages is Paraha from Amazonian Brazil, but there are a few other known or supposed cases. So how do bases appear from this point? Well, speakers will need something to count against, so they know how far they've got. The most universal thing in human communities is the human body, and there we find our answer. Base 10 is the most common, because we have 10 fingers in total, and the hands are the most easily accessible part of the body. So, let's go through each major base and see where it comes from. As mentioned, base 10 comes from the 10 fingers on our hands. Base 5, therefore, comes from the fingers on just one hand. Base 20 comes from adding the 10 toes in, and base 6 is similar to base 5, but also uses a closed fist as an additional unit, and this may in some cases have been used across both hands to represent base 12. However, the more customary explanation for base 12 is that it counts the 12 knuckles on one hand. The thumb is excluded in this system, as it's used to point to the relevant knuckle. This can then be combined with the 5 fingers of the other hand, which are used to indicate each completed set of 12, giving the basis for base 60 systems. Bases 4 and 8 come from the same practice of counting the gaps in between the fingers rather than the fingers themselves. There are some languages which have more complex systems than this too. For instance, the Phoi language of Papua New Guinea uses a system where every number is denoted by a body part, and counting starts at the tip of one hand, along the fingers, up the arm, over the head, and then back down the other side. This makes for a total of 37 numbers, but with the added complication that left and right body parts aren't distinguished, so half the words are the same as the other half, with the exception of the midpoint. To distinguish, speakers likely use visual clues or context. I've mentioned a couple of times how some languages have systems involving multiple bases. So how do these work? Well, if we look at numerals in the Inupiaq language of northern Alaska, we see that it uses a solid, extensive base 20 system. However, below 20 we don't see 20 unique numerals. Instead we see a regular base 5 system, where each multiple of 5 is derived from words referencing the fingers and toes, as may be expected from such a system. Since each base is used in different parts of the numeral system, they don't interfere with one another, so the language can be said to have a mixed radix. Basque of northern Spain and southern France uses base 20 up to 100, where it switches over to base 10. Wolof, a language of Senegal and neighbouring countries, uses base 5 up to 10, where it switches to base 10. French uses a particularly unusual system, where it's base 10 up to 70, base 20 between 70 and 100, then switches back to base 10. Between 70 and 80, it uses an impure vigesimal system built on the word for 60, while 80 to 100 uses a purer system expressed in terms of 20s. The native numerals of the Madi language, which I recently made a video on, are base 2 up to 5, then base 5 at least up to 10. However, in addition to these native numerals, Madi, as well as many other languages, uses a second set of numerals. In its case, these are pure base 10 numerals, borrowed from Portuguese, but systems in other languages may be either of the same or a different base, and may be either borrowed or native. Korean, for instance, uses base 10 numerals borrowed from Chinese, alongside its native base 10 system. These two systems are used in different contexts, and only Chinese-derived numbers are used above 100. The Welsh language uses two systems as well, but unlike Korean, these are both of native origin and differ in base. The older system is mixed vigesimal, using base 20 up to 100, then base 10 above that, much like Basque. The second system, which is a more recent development, is solely base 10, and likely developed under the influence of English. Another factor that may have driven the uptake of this system, though, is that Welsh, like all other European languages, writes numbers using Arabic numerals, which are base 10. These are the symbols we use in English, which works fine for those of us with decimal languages, but doesn't match very well with other bases. In English we write the number 10 with a 1 and a 0, but in an equivalent vigesimal written system, 10 would have a unique symbol and 20 would be 10. The uptake of education in the UK during the 1880s onwards meant more and more Welsh people were using base 10 numbers in writing and when speaking English, so this influenced the spoken Welsh language. Many other non-base 10 languages also use the Arabic numerals, but not many of these have altered their speech as Welsh has. Yoruba, for instance, uses a very complicated base 20 system, but writes the same base 10 numerals. Other written numeral systems do exist, and if they're used for non-base 10 languages, they'll generally be better at representing this automatically. The Inupiaq language, which we discussed earlier, has its own set of numeral symbols, known as Kaktovik numerals. Since the spoken language uses bases 5 and 20, the written form shows this, with 20 unique symbols between 0 and 19, with repeating patterns every 5 numbers. Larger numbers are shown exactly like in Arabic numerals, with zeros at the end to denote a round number, although this is scaled to base 20. A 1 followed by a 0 represents 20, a 1 and 2 zeros represents 400, and a 1 and 3 zeros represents 8,000. This is known as a positional numeral system, but there are other systems that don't work like this. In Roman numerals, for instance, each symbol represented only one value, regardless of where it was placed. An I only represented a 1, a V only represented a 5, and an X only represented a 10. The order these symbols were placed in denoted simple addition and subtraction to reach the desired number. If a smaller numeral was placed to the right of a larger one, they were added together, while if it was placed to the left, it was subtracted. So VI represented 6, but IV represented 4. Traditional Greek numerals are somewhere between these two systems, having a unique letter for every number up to 10, then for each 10, each 100 and each 1000. Unlike Roman numerals, however, a larger numeral always precedes a smaller one, so they're always added together and not subtracted. To write 382, you need the symbol for 300, the symbol for 80, and the symbol for 2. Since the letters of the Greek alphabet are used for these symbols, a bar is then drawn over the top to differentiate them from written language. Various other languages have used systems like this, such as Armenian, Coptic, and Hebrew. Hebrew writes right to left, so the order of these numbers is reversed compared to Greek. There are also examples where this extends even to clocks, so that they run anti-clockwise to match the numerals. Another feature of the Cactavic numerals we discussed is that they're iconic. That is, they visually represent the number, so 2 has 2 vertical lines, 3 has 3 vertical lines, 4 has 4 vertical lines. Since they use subbase 5, each additional 5 has a horizontal line, and the in-between numbers extend below it. The other written numeral systems we've discussed are all non-iconic, where the written numeral gives no indication of the meaning. Mayan numerals fall into the former category, using dots and lines to represent the numbers, with repeating elements every subbase. So, in English, cardinal numbers are generally classed as determiners, along with articles, demonstratives, quantifiers, and several other words. In other languages, though, they don't always fill this role. In the Big Nambus language of Vanuatu, for instance, numbers are a subgroup of verbs. Speakers would say, "we are two," to mean there are 2 of us, and if they wanted to say the 2 children, they'd say something like the children being 2. In other languages, numerals may act as nouns, adjectives, or be their own class of words. Other types of numbers, which we'll discuss shortly, may fill different parts of speech to cardinals. In English, for example, we have number forms that are adjectives, nouns, adverbs and affixes. Our ordinals are adjectives or nouns, while in Big Nambus they're always nouns, which can then occur in possessive constructions to represent which one of something is being discussed. So far we've mostly been discussing cardinal numbers. These are the base words used for counting or numbering objects. But within a language there are also often number words used for different purposes. English has a particularly large assortment of these. But let's go over some of the more common ones found in the world's languages. An ordinal number is used to indicate which item of a numbered sequence is meant. In English, these are the words like first, second, third, fourth, fifth, and so on. As mentioned, they usually occur in a form that can be attributed to a noun in some way. An adverbial number, unsurprisingly, is an adverb. These generally express how many times something happens. Once, twice, thrice. While English only has these 3 adverbials, other languages, such as Latin, have regular ways of forming the adverbial of any number imaginable. A fractional number is a word for the denominator of a fraction. In English, these are mostly identical in form to our ordinals, but some of the lower numbers have distinct forms: whole, half, and quarter. A multiplier is used to express how many times something is multiplied. It's not used in English as much as other languages, but can be formed either with the native fold suffix, or by use of a word borrowed from Latin. A distributive is used to express how many of something there is per unit of something else. Again, as separate words, these are rare in English, but used more in other languages. And in English we have a range of other ways to express them. Think doubly, 2 by 2, 2 each, and in twos. Collective numbers are nouns referring to a certain number of something. In English we have words like pair, trio, quartet, dozen, score, and many others. We form these in several ways, and some cardinal numbers have multiple associated collectives. In some languages there are different numeral words, even of the same class, used for counting different objects. In the Pingalapese language of Pingalap in Micronesia, there are different number words for long nouns, animate nouns, small nouns, non-specific nouns, and other nouns. Other languages distinguish different categories and different numbers of categories. I mentioned earlier Korean numerals, where one set of numerals is used for counting and age, while another is used for dates, money, and phone numbers. This phenomenon is closely related to another, that of classifiers. A classifier is a word or affix which accompanies a noun in certain contexts in some languages. Most often this is with numerals, but there are often a few other situations where it's necessary to include them, such as with determiners. The construction is comparable to measure words in English, such as blade, as in blade of grass, or bottle, as in bottle of water. These classifiers are chosen on semantic grounds, so in Chinese there's one classifier for long objects, another for flat objects, another for livestock, and so on. These systems are generally very extensive. Korean has around 200, although only a few are particularly common. The Nivk language of Siberia has at least 33 classifiers, which are attached to numerals, although the exact nature of this system is debated. So, that should about do it. I haven't discussed everything to do with numbers, but hopefully I've given a good rundown of everything major. All going well, there should be a bonus video out this month, so keep an eye out for that. Thank you for watching.